Before the session ends, Childress will work with her volunteers so they're not left in a state of craving drugs. On the streets of Philadelphia, Ron and Tony are helping Childress create authentic videotapes.
Okay, so let's start talking a little bit about what the bag's going to be like. The fact that you've heard it's really good stuff.
Both Ron and Tony have been battling heroin addiction for decades.
Octopus was out, and I just shot it out, bagged it out one day, man. I crossed my knees, man. My eyeballs.
I ain't had no joke where I crossed my knees in a long time. Yeah.
Describe the pleasure you get out of that first high, that first rush.
Hey man, it's a utopia. It's like when you reach your climax, man.
An orgasm.
Yeah, it's like when you come to your climax. Wow.
That's perfect. In fact, he describes it spontaneously that way, but our patients often use sexual terms to describe this pleasure because it's certainly on that dimension, but what they will usually say is that it's very often like orgasm, but many times more strong.
Yeah,
But what happens the second and third time?
Well, that's when you see. This is one of the reasons you get hooked. Now we keep trying to find that first time. That first time is the greatest of
You
all.
always want to get back to the first time, but you can't.
That's why we keep on. You keep on trying to find that first time again, and you never find it.
I'm getting high for 30 years. I'm still trying to get it back again. I mean, the first time was just the ultimate, man.
What was it? What drug?
First time I was shot was crystal meth.
Crystal
Meth, speed.
Speed.
And it was like, I mean, it knocked me with my knees, and I came with my pants. That's how strong it was, the rush. And I go through about anything just to get a shot sometimes. I mean, it takes away all my problems of the day, or it takes away everything, man. It just numbs you.
And importantly, for all of these drugs, the vulnerability to return to use, the pull, going back, that tendency, the cardinal feature of addictive disorders across the board, and it's there long after any withdrawal symptoms have ceased.
So the body
Long
remembers.
after the body remembers, and there's this desire to recapture that experience and to relive it again and again and again.
I've been in jail a few times, and I detoxed in jail. You know, you're sick for days and days. And like I said, I'll never do it. As soon as you get out, man, you're back doing the same shot again. I mean, I couldn't be out an hour. And I have, I've already kicked in. Time's been gone by. I did 6 months in jail.
And you don't want to go back to jail. You don't want to go back to jail.
The first day I got out, man, I did a shot. It's like,
Why?
I don't know what, I just love that high. I mean, it's just like,
It's a
it's
magnet.
immense.
It's a magnet. It's like
Can't-
a magnet.
What can't compare?
Heroin, the feeling is a magnet. I did 3.5 one time because I swore
In jail?
and swore I wasn't going. And man, I wasn't home in an hour. I wasn't home in an hour. But
Yeah, man, I was sick.
all right, one minute.
Many addicts report the same experience of being pulled back to using. It's as if something turns on the autopilot to relapse.
Talk a little bit about the feeling that you sometimes get as you're about to get close, though it's almost like you've already used it.
I mean, just knowing that you're getting it is like, you always feel it, especially when you start cooking it up and smelling it, man. It's like,
You know, man, when you put that fire in that, that smell that comes off of there, man, it's,
it's a high spot. You know,
you know, man, you know, you get ready to
That's
get
an
on.
important thing, actually.
How's that?
He's describing that when he actually begins to cook up, that before the drug ever gets in the syringe, before it ever touches his arm, that he begins to feel a little bit of the high feeling before he even gets there. In animals, we've been able to see, when you put down little probes in the brain, that when you have things that remind the animals that a cocaine injection is coming or a heroin injection is coming, that it leads to an increase in the same chemical messenger in advance of the drug ever getting there that the real drug produces, like an increase in dopamine, the chemical messenger we've been talking about.
Go around the block, man, make it back up on the corner.
It's the simplest kind of association learning, and it's very powerful.
All right, man, listen, I'm gonna go back in the cup, open the dude's here.
So now seeing a certain street corner or seeing someone get high on a videotape or even in real life means opiates may be coming. It's not exactly a memory of, oh, I was on 38th Street and I remember. I know what this feeling was like. It takes me back to the feeling. So it's a feeling memory, and that's important.
And emotional.
Emotional memory, feeling memory.
Emotional
emotional memory has literally the emotional content or meaning attached. What emotion does is it evaluates something, gives it its significance for us. When you use drugs, for example, not only do you remember the experience, the euphoria, the high, but also the scene, the precise scene, who you used it with, where you used it. Now, one of the things about emotional memory, which is so important, is that they are powerful and long-lived because they're associated with survival. You know, if sex weren't rewarding, nature's experiment with sexual reproduction would have been a failure.
If we didn't have sex, we wouldn't recreate ourselves. But when we have sex, we say, hey, that was good. Let's do it again.
You remember it. In the case of positive emotional memories, we think that the chemical dopamine is what's involved as marking them as survival enhancing. So when you encounter a wonderful new food, a wonderful new experience, dopamine is released. The next time, when you anticipate getting that new food, having that experience again, dopamine is now released in anticipation. Now, where the emotional memory is stored in response to these survival-enhancing positive memories is not yet entirely clear. Actually, the amygdala may play a role. So might the nucleus accumbens, which we've been talking about, but so might other parts of the brain. And one of the long-term hopes of this kind of approach in humans is that we'll be able to map exactly where these emotional memories are stored.
The amygdala, an almond-shaped structure in the brain, lights up on the screen when Childress takes PET scans of the brain during drug craving.
What we're able to see is that when our patients are viewing videos that remind them of their drug and entering this state of craving or desire, this structure seems to be differentially activated. When they're looking at nature videos from public television, the amygdala is not really all that interested. Another structure in the brain that seems to be differentially activated during this state is something called the anterior cingulate. So what we see here as sort of a developing signature of craving in the brain is that these structures are saying something emotional significant is about to happen. Okay, to what degree, 0 to 9, are you feeling any craving or desire for heroin at the moment? If we ignore these desire states that seem to persist long beyond the last use of the drug, long beyond the last sign of any withdrawal symptom, then we'll be missing the boat. And so part of our effort here has been to focus on developing strategies, whether they're behavioral strategies in terms of talking therapies to help people cope with these states when they're triggered, or whether it's medications that we would like to basically have that would be helpful in tuning down the compelling quality of this craving, not to the point that a person is without desire, because a person without desires is numb, and no one would want to live that life, but to put them in a range that would be more manageable.
Diamonds double strategy DNA.
Scientists working in the addiction field are studying all kinds of medications, vaccines, and therapies for their potential use in treatment. Their research often comes back to real-life experience.
I have been touched by many people who have been profoundly affected by addiction, both one branch of my family and one of my closest girlfriends, who is my age, just passed away several months ago from long-time abuse of alcohol and cocaine. So if I could do one thing in my life, it would be to discover some possible pharmacological treatment that would give people, individuals who find themselves profoundly addicted to these substances, just something that would even take the edge off for long enough to enable them to get on their feet, just enough to give them a chance through psychotherapy, through group work with other people like themselves, and fulfill their potential as humans.
Is the brain of the addict different? I think it's clear that after they become a drug addict, their brain has changed. And it's probably changed forever. The real question is the brain of a potential addict different than the brain of a non-potential addict? And that's an issue that's still being explored. Large proportions of people who use drugs do not become addicted. Most people who drink actually a large proportion of people who use heroin don't become heroin addicts.
Why can I have 2 glasses of wine and won't no more? And yet, my good friend can't stop at 6. Is that what you're asking?
Yeah. I mean, we can only speculate at this point, but maybe someone has higher endogenous levels of stress hormone. Maybe someone has a deficit in dopamine function or a hyperdopamine function. We don't know at this point. That's going to be the real challenge for future work.
Trying to identify who's at risk.
Who is at risk and how to translate the information that we gain from the animal studies to the human study.
One explanation is simply that you induce processes that degrade the RNA.
One clue to discovering who's at risk for addiction lies in the genetic code that makes every human being different, that gives each brain its own signature.
What's the first gene you're going to put in the cell? This group of people is discovering genes that are regulated by drugs and what they do inside nerve cells.
What researchers want to know is how biology and biography produce addiction.
It is clear that the brain is built in interactions between your genes, what you inherit in your DNA, and the environment. It's really striking. There are about 100,000 genes that go into making of a human being. About 70,000 of them are expressed in the brain. So the environment has to work together with the genes to build the brain. Having said that, we emerge in childhood or later on with real differences in our dopamine system, in our nucleus accumbens, in different parts of our amygdala. That's part of our own natural diversity. It's that combination of the thermostat being set differently in all of the different circuits in the brain that makes one person more likely to try drugs, makes a person more likely to get caught if they use drugs. But obviously, none of these things are genes alone or environment alone.
Your father was an alcoholic, and so was his father, your grandfather. Any others in your family?
I've got 2 sisters who are also drug addicts, alcoholics. It's throughout my family.
The risk for developing alcohol dependence is 4-fold increased over the general population if you have a close relative with alcohol dependence.
Alcoholism runs deeply in my family.
Parents?
My parents, my grandparents. It cost me, my mother died from cirrhosis of the liver. She was 35 years old. My father died when he was 39.